Okay, welcome back. In this video, we're gonna try to solve the following two equations. The natural log of x plus 2 plus the natural log of x plus 3 equals the natural log of 6. And the natural log of x plus 2 times x plus 3 equals the natural log of 6. So in these two equations, they seem like the same. But if we take a moment, they don't look alike at all. They might have some common elements, but they are different. To see why, let's solve the first one. So our first equation, let's call it 1, and let's call this one 2. So to solve the first one, we have the sum of two functions. Okay? So we have ln of x plus 2 plus ln of x plus 3 is equal to ln of 6. So to have this one defined, we need to have x plus 2 strictly bigger than 0. And this one, x plus 3 bigger than 0. Okay? And this is defined because 6 is positive. So this condition here, these two conditions gives us that x is in this interval, minus 2 plus infinity. So because we need x to verify or to satisfy this condition. So its x has to be here. It's easy to see that x plus 2 bigger than 0. That means x is bigger than minus 2 and x is bigger than minus 3. So minus 3, minus 2, and we see that they do intersect when x is bigger than minus 2. Okay? So given that we are in this interval, this one is positive, this one is positive, so we can multiply. So we can get ln of x plus 2 plus ln of x plus 3 is equal to ln of x plus 2 times ln of x plus 3. And this one equals ln of 6. So now we can get the exponential to get x plus 2 times x plus 3 is 6. So factoring out, we get x squared plus 5x plus 6 equals 6. So adding 6 to both sides, we get x squared plus 5x equals 0. And here, when we factor out, we get x times x plus 5 equals 0. That means x is 0 or x is minus 5. But only 0 belongs to this interval, to minus 2 plus infinity. Minus 5 doesn't belong here. Therefore, the only solution for this system here, this equation, is 0 only. If you plug 0 here, you get ln of 2 plus ln of 3. Both of them are positive. You can multiply. So therefore, ln of 2 times 3, which is 6, and we get the result. Now, let's solve the second one. Okay? To solve this second equation here, we need to have the domain of definition for this one here. So in this case, to find the domain, we need to make a small table. Okay? The easiest way. So what are the solutions for the equation x plus 2 times x plus 3 equals 0? We have minus 3 and minus 2. So here, x can go from minus infinity to plus infinity. And here we're going to get the sign of x plus 2 times x plus 3. We'll see where this one is positive. So when x is minus 2, x plus 2 is 0. When x is less than 2, it's negative. When x is bigger than minus 2, it's positive. For this one, when x plus 3 equals 0, when x is minus 3. If x is less than minus 3, it's negative. If x is bigger than minus 3, it's positive. And to get the sign, we just multiply. So on this interval, minus 2 plus infinity, both of them positive. So we have positive sign. So on this interval, minus 3, minus 2, one is negative, one is positive. That product is negative. On this interval, minus infinity, minus 3, both of them are negative. So when we do the product, we get positive. Okay? So from here, we read the sign, the positive one. So we come in from minus infinity and we hit minus 3. That's it. And we go to minus 2 plus infinity. So this is the domain. Okay, for this one. So assuming any x in this domain for this second equation, assuming that x belongs to this one, we have ln of x plus 2 times x plus 3 equals ln of 6 equals x plus 2 times x plus 3 equals 6. Okay, x can be in this interval. Okay, so here doing the same thing, we get x squared plus 5x equals 0, and we get x is 0 or x is minus 5. Okay, so is 0 in this interval? Yes, it's here. Is minus 5 in this interval? Yes, it's here. Okay, therefore the solution for this one are 0 and minus 5. Okay, so we don't just apply we don't have ln of AB is ln of A plus ln of B. Okay, so we can do this one here for these two. Okay, remember, when A and B are both positive, you have this one. Okay, so that's the issue. So we need to have this quantity positive to be able to do this distribution. Okay, anyways, we see that the solution of the two systems that two equations that they look the same is different. So the key idea is that we get something given two functions. Okay, given a function defined by f of x, ln of x plus 2 plus ln of x plus 3, and a function g of x, ln of x plus 2 times x plus 3. Okay, these two functions are different. They are not the same, except when we are in this interval. They are the same on this interval, minus 2 plus infinity. Okay, they are not the same. Basically, if we need to have f equal to g, we need to have them have the same domain, and they have the same behavior on everywhere. But they don't have that. So that's why this function f is different from g, and that's why we have this one is different from this one. And that's why we have two different solutions, this one and this one. If you want to see more, graph this one. Graph this function using the calculator, and graph this one using the calculator. TI 89 or 84 can do it very quickly. So do this one and do this one, and you're going to see the difference. Thank you.